Hello and welcome. I'm Matt Brandon, class of 92 and Associate Vice President for Alumni Engagement and CEO of your William and Mary Alumni Association. Thank you for joining us for this third session of our AI for All program, which is part of the Alumni Association's Lifelong Learning series. Over our first two sessions, we explored the fundamentals of artificial intelligence and then moved from understanding AI to putting it into practice. Today, we're building on both of those conversations with a session designed for those who have a little more experience with AI or feel more comfortable using these tools and are ready to take the next step. If you missed either of our previous sessions, recordings are available on the Alumni Association's YouTube channel. We're fortunate to once again have Dean Doug Schmidt, inaugural Dean of William & Mary School of Computing, Data Sciences, and Physics, and Dr. Dan Runfola, Chair of William & Mary's Data Science Department, leading us through today's program. A couple of quick housekeeping notes before we begin. Again, today's webinar is being recorded and will be made available on the William & Mary Alumni YouTube channel. For those who want to revisit or share with others, you will find the content there shortly. We will have some time for Q&A after the demonstration, so we encourage you to submit your questions through the webinar using the Q&A panel, and we'll do our best to answer as many of your questions as possible. Thank you for joining us and for continuing to explore how AI can enhance the way we work, learn, and engage with the world around us. And thank you for participating in this program provided by your Alumni Association. With that, please join me in welcoming Dean Schmidt and Dan Runfola.
Thank you so much. Appreciate the introduction, Matt. I'm going to say just a couple of things real quick, and then I'm going to turn it over to my colleague, Dan, for the first part of the tutorial. And then I will come back and talk about the next part where I'll give a different perspective or another perspective on using agentic tools to solve all kinds of interesting everyday type tasks. So with that, let me turn it over to Dan.
Thank you very much, sir. Let me get my screen shared. All right, we'll see if this works. All right, what are you guys looking at? This look right?
You use the whole slideshow thing. It's showing up the view where it has, yeah, perfect.
There we go. Good, wonderful. So today we'll be talking a lot about agentic design with artificial intelligence. So previously we've talked a bit in this series about prompting and different strategies for prompting writ large. Here we're going to be exploring this kind of novel concept of building AI agents that take on different roles and how working together they can then build new platforms, documents, all sorts of exciting things in much more detail and with much more accuracy than individual agents can do alone. Sorry, wrong. There we go. So when I talk about this, I want to talk first a little bit about definitions. So when we talk about an agent, we are really talking about AI that can plan steps. So before it actually does anything, it will think through what the actual steps of the analysis would be. It can use tools. So tools are any interaction that an AI can have with your computer. So many tools in things like ChatGPT are built in. So you might have tools that let the agents access your email accounts. You might have tools that let it interact with Word, for example. And you can also build your own tools. And you can also have agents, they're always working towards some goal. So there's some established outcome that they are trying to reach. Agentic design is kind of a wrapper around how across different agents you coordinate them to actually take on different roles, different tasks, the different types of actions we're asking these individual agents to take, and how we're actually coordinating that across a group of different agents. What I'll be really, really focused on here is how we can tell these teams of agents not only how to work together. It's pretty easy to do that if you've used modern day ChatGPT, specifically the paid versions. They have really good agentic interfaces. What we're most interested in is how do you make it so you can have them give you consistent results with a single prompt? So as opposed to having a long back and forth with these agents, a long back and forth with ChatGPT, how can you make it so you instead just have one big prompt you can copy paste, use as many times as you want? So when we think about these kind of agentic designs, really what we have to do is we need to think through different steps of how we want to construct this prompt. So first, we need to actually think through how many different roles we want. How many different agents do we want? You don't have to specify this, but if you don't, then the AI tools will guess for you how many agents they should use to accomplish a task. That's fine, but it will result in different outcomes because you'll effectively be building a different team every single time you run your prompt. So what we're going to think through here is what is the team we want a priori so that we get more consistent results. We then need to define for each one of those individual teams or these individual agents what we want them to be accomplishing. And then we need to set up agents that will actually review that work. So I'm going to walk through this kind of under the auspices of a very, very simple example, which I set up for you guys here, which is something we're working on right now with Homecoming, which is planning a lunch for alumni. So we're starting to think through how we're going to bring some alumni in to meet with some of our current students. So how do we actually go about that? Now, the way I do this as the chair of the Department of Data Science is I ask Adrian, my wonderful administrator down the hall, if she could find the best event. Could she actually make sure we had the money for it? And then could she actually put together the guest list and order the food? As a practical matter, agentic tools need those tasks broken down into individual tasks that one agent can perform. So we could have one agent that is the venue planner. It's the agent that's going to find all of the available spaces out kind of in my case, in my building, Integrated Science Center 4. We might have one agent then is looking at the budget and making sure that we actually know how much everything will cost and that we have enough money to do it. And then another agent that's working on the food, right? Making sure that all of the allergies are accounted for and all of that. And those agents can then work together to actually plan the event. So you can imagine different ways you could prompt AI to accomplish the same task. So the simple way that you might start, and again, this isn't wrong, is you might say, plan an alumni event for 20 people in Williamsburg, Virginia. That could be your entire prompt. The agent will start working, and you'll have to then talk back and forth with that agent a number of times to get the kind of result that you need, because you've left the agent a huge number of degrees of freedom. There's a lot the agent has to kind of guess to figure out what you actually need. When we think about doing the same thing, but in a reusable context, we have to think through where we can add specificity. And so this is a very simple example. I'm going to walk through a slightly more robust example in a moment. But you can think through, planning an event in Williamsburg, Virginia, using my website and the attached guest list to actually help to plan that event. I can tell the AI to explicitly use a planning agent, a budget check agent, and a guest list and food agent. So it will create 3 different agents that will work on this problem. I can tell it explicitly what I want in terms of the meeting. What I'm doing here is I'm reducing those degrees of freedom. I'm making the request more specific so it will be more reusable in the future. So let's talk through this in a more robust example using a more discrete and well-defined framework. So for this presentation, because I'm an academic and I'm naturally drawn to, nice little wordplay, I put together a 5 different section prompting strategy that reflects what we use when we're trying to build these reusable prompts. All of these letters worked quite well except for N. Norms is a little bit of a reach, but everything else I thought dovetailed quite nicely. So our agent strategy for prompting. So we'll walk through these. So A, the first kind of critical things you have to include in your prompt are the aim, specific questions that help the agents understand what they are trying to accomplish. So here, this really reduces down to 3 key things. It's what output must the team of agents produce, who will use the output, and which conditions must the output meet. So trying to explicitly make sure that the agent knows exactly what it's trying to produce and for whom it is trying to produce. So for grounding, this is really about the context. So all of the different files, facts, links, everything for the agent. The next thing is ecosystem. So this is where we are going to define our team. What are the agents that we want to actually execute on our task, and what do we want them each to do? So there's lots of different ways to do this, and there's not right or wrong ways to do this. You can decompose your problem in lots of different ways. The more specifically you can define this, the more replicable your prompt is. So in this example, we might have a lead agent that's actually kind of coordinating everything, a fact finder agent that's going out and searching for available venues, a draft writer agent that's going to take in all of that information and put together a report, and then a reviewer that is actually testing if those results meet all of our kind of qualifications. But you can, again, like, it's kind of up to you, and you can test different ecosystems of agents and you can see how they perform better or worse. And it's pretty straightforward to do because you can define these in text in your prompt. Next is norms. So this is, again, I stretched a little for using norms because I wanted to spell the word agent, but bear with me. This is where we really want to define what our agents are and are not allowed to do. So you want to be very explicit about this. Depending on the tool you're using, some will allow agents to run wild, and some will actually kind of have them in a sandbox. But I always like to tell it, it's allowed to do blank, read my files, draft my plans, the things I want. I don't want it to actually book or buy anything for me or send messages without asking. A great example of this, if you have an agent and you're asking it to find venues for it, on the basic ChatGPT versions, when they have access to like my email on my desktop, it will freely send emails from me to venues to check if there's availability, right? It wouldn't even think to ask that unless I specify it shouldn't. Now you will have your permissions set up differently than mine, but when you give it free reign, it will take advantage of that. And then finally, making sure that it knows not to do certain things. So hiding facts, inventing prices. You can really think about this as an employee, where you want that employee to have, you're the most micromanaging manager you can imagine. You want to tell your employee exactly what you want and exactly what you don't want. And then finally, I think the last and probably most important is tests. You want to be very explicit about what it is you want them to test, how it is you want them to revise, and how it is you want to retest. So you want to make sure that that is clearly defined in your prompt. A few side notes here before I show a real example of this. So you don't have to use multiple agents, and there are costs to using multiple agents. If there is a case that you have where you only need one agent and there's, all required tasks can be completed in serial by one agent, it is simpler and cheaper to do that. So you really do want to ask yourself before building an agentic ecosystem, as cool as it is to see agents working together, if you need it. So generally, there's some triggers where you want to start adding more complexity. Things like if you have different tasks that can start without waiting for each other. So if they can all run at the same time. If you have different roles that are actually producing different explicit deliverables, it is useful to have different agents. And then finally, you always want to have a different agent when you're doing testing. So if you want to do quality assurance, you want a new agent to do that, not the original agent that produced the task. Again, there's an obvious analogy here with a real workplace. You don't want the person who is creating the thing to be the one that assesses the thing, unless it's Boeing, I guess, in which case we trust them to do both. But for the most part, right, we want to make sure that we're not having the same agent do a creation and a test of the same item. The reasons for this are threefold. First is that you're going to have more token use for more agents. It is more expensive. There's more handoffs between agents, and that can take time to actually send information from one agent to another. And then finally, every agent you spin up has to have its own setup time. So it's creating a new agentic interface, and that can get non-trivially expensive. For those of you that have used kind of the pro versions of ChatGPT, the desktop versions especially, some of these things can run for 10, 15, 20 minutes. The examples that I put together, one of them ran for an hour and a half. So these are not computationally quick things to run. So I'm going to give just one kind of full example and then two follow-up examples where I'll just show you the output. So this full example is me, again, trying to find a lunch venue for 20 alumni. So you can see where I've defined explicitly all of these different components. And this is the actual explicit information that I would then put this whole thing as one prompt into ChatGPT. And it's important to put all of this in as one prompt because that way it will learn all of these different rules and guidelines at the same time. So you can see here, first and foremost, I want to define my task. So I'll actually have my task in terms of what its outputs are, what I'm trying to accomplish. Immediately then explain the different agents that I want. So you can go in and you can actually explain you want the lead agent, the local guide, the cost reviewer, all of these different agents that I want, my final reviewer agent. And then on the right-hand side, you'll see all of the rules and tests that I want those agents to operate under. So first thing I'm defining is how I want those agents to interact with each other, how information is being passed between different agents when those agents are being run. I'm making sure that all of the tests I need are explicit. So making sure the venue has at least 20 room for 20 people, how much it will cost. There's gluten-free food available for our participants. The rules that I want my agents to actually follow. So I want to know what the lowest total cost venue looks like and how I actually want this returned to me. Finally, I did want to explicitly say I don't want any contact. I don't want these agents writing emails, and I don't want them booking things on my behalf. Because again, how I have my systems configured, my agents can interact with tools that would allow them to do that. And so you want to be careful to always tell your agents what you don't want them to do. You can visualize this agentic workflow as a flow here that shows where all of these different agents might interact with one another. So the prompt that I just created creates this set of agents where we have a lead agent that is actually handling all of the coordination. We have the local guide, which is looking in and finding all the facts about the venues. We have our cost reviewer and our guest list kind of access and food person that can work in parallel. All of those pass their information back to our lead agent, which then combines everything to create the final report that it passes to the final reviewer. What in this particular example here, so having kind of just dumped this entire prompt into ChatGPT, you can see this kind of overall summary of the types of information that it found. I'm actually not going to belabor too much the outputs here because this was just the example case. What I do want to show you is outputs from two other cases that I did that have, I think, some more complex prompting strategies, but create some really, really interesting outputs. All right, so the first one of these is a proposal building tool that we were working on here in the department. So one thing that we get periodically at the Department of Data Science is companies that want to collaborate with our faculty members on various kind of applied projects. It's a little bit hard for us to scope out the budget for those, to write email responses back to those. So what we did was we put together one of these prompts that is set up to build web interfaces. So this particular web interface has a team that we've already defined. So a team of web design coders, backend coders. Some of the agents are responsible for quality assurance. There's one that's responsible for Mac OS testing, one that's for Windows OS, one for Android phones. And this ecosystem of agents then receives an instruction of about one paragraph of what is the app that you would like to build. And so this particular app was one that we put together that is, you can copy and paste an email from a client, and it will automatically create these proposals for you, automatically draft email responses back for you, estimates of how much it might actually cost to do the thing that the client wanted to do, flag any risks, flag any assumption that it's making. That's pretty cool and actually handy for us. But the last thing I want to show you is how flexible these agentic teams are. So with the same prompt, where we took all of the same agentic tools, all of the same agentic roles, I gave that to my 9-year-old daughter. And I said, 9-year-old daughter, type in your one paragraph description of the website you want to create. And so my 9-year-old daughter created Snack Cat, where she typed in, I want a video game that allows my cat to go and eat sweet stuff. So within about, I don't know, this took my daughter maybe a minute to type in. She now has this team of agents at her disposal, and she can create websites where her cat is no longer allowed to eat broccoli or she loses the game. So again, these replicable strategies for building agentic teams allow you to very quickly create new websites, new tools, new reports using the same types of structures that you've built before. And with that, I'm going to pass the hat over to Doug.
Great. Thank you, Dan. Let me see if I can share my screen. Looks like I can, which is good. Let me hide the controls. All right. So welcome back to the second half of the tutorial. I'm Doug Schmidt, as before, and I'm going to go ahead and give a little overview of using agentic AI to leverage and extend some of the things we had talked about in our last time together. So if you recall what we covered last time, I mentioned how I like to use AI in my daily workflows. Visual storytelling, this is an example of that. Education, this is an example of that. Professional writing, not so much an example. Knowledge synthesis, pulling together different pieces of information from different sources and making a coherent story, that's part of this. Idea generation, and then strategic planning. And that's actually what I'm going to be talking about here is my case study example, as you'll see. So as before, all those different daily workflows feed into my computational thinking process. And more I find myself using AI to extend and enhance that computational thinking process. Last time, we talked about an example that used so-called AI augmented problem solving, which we'll review briefly. This time, we're going to focus on using scalable agentic tools. And in particular, we're going to show how to use Google's Opal tool, which is a freely available tool to anybody who uses Google products and has a Google account. So let's take a look. If you recall, the example we looked at last time was something that came up a number of times throughout the last few years where we wanted to organize a faculty retreat. And in this case, we had 35 professors. We wanted to have 5 discussion groups with exactly 7 professors per group. And this was what I had done last time. So last time we got together, I showed how we solicited ideas from faculty, stuck them into a Google Doc, used ChatGPT to cluster the topics, used ChatGPT to generate a Google form, sent that Google form out to the faculty to get their choices. We then used ChatGPT to assign the faculty to groups, and then the faculty got together and talked about the different topics at the retreat. And as we saw, it was way more efficient to do this with ChatGPT than to try to do it the old-fashioned way with either writing code or doing the assignments and the clustering by hand. So the basic workflow here is collect raw ideas. First, synthesize those ideas into several sets of discussion topics, gather the choices of the faculty, and assign everybody to the groups. That's the kind of overall workflow. And this was well welcomed. It was great to use ChatGPT. It did a lot of the heavy lifting, but the overall workflow was still manually orchestrated end to end. So what does that really mean? Well, it meant that we had to do manual handoffs between those different phases. I had to write code, rather generate code, prompt code, and then it worked under behind the scenes in ChatGPT, but I still had to make sure that things worked through manual intervention. There was a lot of hidden state here. The system, the ChatGPT that I was using didn't remember all the things that I was doing. And so if I wanted to come back and do it again, I'd kind of have to start from scratch. The prompting was a little brittle. As you remember, I did some iterations with this. I wasn't using Dan Runfola's cool kind of one prompt to rule them all technique because I wanted to do it a bit more iteratively, but it's a little brittle to do it that way. And the other problem here, really the biggest issue, is it's a one-off result. This worked for me because I knew how to use ChatGPT. But if I wanted to get my other faculty co-leads of the workshop to do this, they would have to come and sit by my side and look at the prompts I was generating, which isn't really very scalable. So what we're going to do instead is we're going to redo this example, except this time we're going to use Google Opal. And we'll use it to create some so-called mini apps, and these mini apps will then automate and coordinate the bulk of the process. And to make this really cool, what I did to make the mini apps in the first place was I went back and extracted 9 minutes from last tutorial's presentation. And then I gave that excerpt to ChatGPT and I said, please listen to my description of this case study and then generate prompts I can give to Opal to create 2 mini apps to automate the process. So the cool thing here is using AI to improve the use of AI. And you'll see that particular theme reoccur several other times as I go through this case study. And so then I used Opal to create a couple of mini apps, and I was very impressed with what it did out of the box. You'll see what it did out of the box in a minute. And then I spent a little bit of time editing and refining the two mini apps that Opal had generated to really make it perfect for what I was trying to do. And when I was all done, I not only solved the problem, but more importantly, I created a pair of tools that I could give out to other colleagues, like my workshop chairs, co-chairs, so they could solve the problems henceforth. They didn't have to rely on me and my wizardry with prompt engineering. So the bottom line is, from a 9-minute case study video, which I recorded last time when we talked, I was then able to use ChatGPT to generate some smart prompts, to use Opal to build some powerful agents, and then we were able to automate this process in a more effective way. So let's take a look at the new approach now that we've got the overall message described. So this particular example is going to show how to map professors to discussion groups with these two Opal agents. We start out much like we did before, getting ideas from faculty using a Google form. This time, however, we use the Opal mini app, which we are calling Retreat Build, in order to cluster the topics into 5 groups and then generate the Google form. So it's going to generate the Google form as a JavaScript script. We then use that because it'll turn this. We can then use this with Google's App Scripts tool to generate the actual form. The faculty then can rank their choices. And then we use the second Opal mini app in order to actually assign the faculty to groups, which is a lot less error prone and manual prompting required, because now it's been turned into a reusable mini app. And then finally, we go off and the groups can discuss the topics at the retreat, just like they did before. Now, what's interesting about this is a change to what we did before with our AI augmented workflow. So the AI augmented workflow was good, but the problem was that we had to redo it each time. And what we're doing here is we're spending a little bit more time up front to build these mini apps rather than rely on ChatGPT. But the good news is, once we've conducted this investment, once we've performed this investment, then we can save time every time henceforth. And that's one of the benefits of using agents. You can build these reusable tools that can help to simplify your workflow down the road. So let's kind of walk through this a little bit, and I'll show you how all the pieces fit together. So as before, we generate the discussion topics with a Google Doc. This is just the same set of topics that faculty had expressed interest in before. That's really no different. Here's where it starts to get different. So what we're going to do is we're going to open up Opal. And when you open up Opal, if you go to opal.google.com and you log in with your Gmail address, then you have a way to build an Opal mini app. And I'm going to show you what it looks like. So you start by clicking on Create New, and it gives you a little window. And what we do here is we have a fairly detailed prompt, in fact, a very detailed prompt that was generated by ChatGPT after reviewing my 9-minute video. And you can see it's 12 pages long. There's a lot of detail in here. And what we do is we then paste that into the Opal browser window, and within seconds, out pops this particular Google mini app. And you can see there's a bunch of different phases and steps that are here. And what I'm going to do now, if I can make this work, I'm now going to go over and show you the live Retreat Builder mini app. And the reason I want to do this is I want to show you a couple of the cool features of Opal. So you can see these are the various steps. You get raw faculty input. That's a user input event. We then have 4 generator events, which, as we'll see in a moment, are described with prompts. They ingest information, they do some transformation, and then they output the results. And these are all essentially connected together by these lines in our graph, in this data flow or workflow diagram. And that, of course, allows the output of one of these generate nodes to be input into other nodes. And we'll look at those in a bit more detail in a second. And the final piece we have here is the output piece. And what this is going to do is it's going to take all the results from the earlier phases, and then it's going to build a dashboard that'll show the results. And we'll look at that in just a second. But what's cool about this and really powerful, once you get the overall layout, you can then go into Opal and you can edit the prompts within each of these nodes to refine and enhance them. So you can see here, we're going to get raw faculty topic suggestions. We'll see how we get those in a second. We then have something that's going to analyze the raw faculty suggestions, and then it'll create 5 coherent discussion themes based on its analysis and clustering of the data that we got from the faculty. And you can see here, this is what it does. And right there, you can see it takes as input the raw faculty suggestions. So that connects back to this node over here. The next thing it does is we take the output, and then Opal will critique the output and make sure that it actually answers the mail, whether it actually does a good job of describing the key topics that faculty are interested in. Here you can see how synthesize 5 themes is the input into this node. The next thing it does is it goes ahead and presents these 5 themes to the user, to me in this case, and it asks for approval or refinement. And so there's actually a button, a pair of buttons we'll see in a moment, that allow the user to interact with the agents as they're doing their work. Assuming that we say, yeah, these 5 topics look fine, then it goes and does a very sophisticated analysis to create a JavaScript program that will create a Google form. So this is what's going to create a script that'll make the Google form. So this is basically a prompt that will create a Google form. And you can see this is a very detailed prompt. To be honest with you, I actually had to go in here and edit it a little bit because it wasn't doing exactly what I wanted the first go around. But the point is that by using the Opal app builder tool, the mini app builder, I can refine the prompts without having to write any code. I'm just describing it what I want. And then the final thing it does is it takes the information that's generated from these 2 other phases, and then it builds an HTML page that will display the results. And the most important thing that's going to display in the results will be the actual JavaScript code, which we can then cut and paste and put into the Google App Scripts program synthesizer. So those are basically the steps. And the main thing I want you to come away with from here is the realization that you can do all of this and refine it without having to write code. You're working within the wonderful environment that Google Opal provides. So now that we've looked at that, let's go ahead and take a look and see what happens when we actually run the script. So here you can see it prompts us for entering the set of topics that the faculty are interested in discussing. It then goes off and thinks. You can see it going through those different stages in the workflow or the data flow diagram. And now it's going to tell us the results. It's going to organize it into 5 different themes. There's a governance theme, a curricular innovation theme, a graduate program recruitment theme, faculty equity and professional development theme. And then there's also, I think the last theme has to do with community integration and inclusive culture. So there's a bunch of things here about curricula and faculty development and grad programs and undergrad programs. And you can see it also tells you what the source of that was. We then say, this looks good to me, click the button, and now it's off to the races actually creating the script for JavaScript and then building the HTML dashboard. And you can see here, once it builds it, I download it. I've now got an HTML file, and this is the HTML file that's generated automatically. So it's got all the 5 themes with a little scroll box. And then down here, it tells me how to build the actual Google form. And it explains how to build it. And then down here, it actually has the Google form. And all I need to do is copy the code. This is all JavaScript code. It will go ahead and take that JavaScript code, and now I can copy it into my clipboard. And then the next thing I do is I come over here and I paste this into the apps script builder that Google has. And then I go ahead and click the run button, and voila, it goes ahead and executes that JavaScript code. It builds the actual form. And then in just a moment, it'll give me the actual link to the form. And then I cut and paste that link, send it out to the faculty who are invited to the workshop, and then we'll keep on with our example. So once we've got this form, which you can see here, which asks for your name and your email address, and then your top three choices in those 5 different areas that were generated by clustering and essentially analyzing what was done by Opal. The faculty then fill out this form, and Google then collects the responses. And as you can see here, it has a response from each of the faculty members who responded to the form. And then it will give you a summary of which topics are of interest to most of the faculty or different groups of the faculty. So you can see this is kind of what things look like when it comes out from Google Forms. This is not really AI per se, it's just something that Google provides for you. Once people fill this stuff out, it then stores the results in a spreadsheet, which is a so-called comma-separated value document. And we take this document, and that is the input that we're then going to give to the next phase in this process. So you can see it has the top 3 choices from each of the 35 faculty who are going to be participating in the retreat. So once we've got all this information, we then use the second Opal mini app. Let me show you briefly how we create the app, and then we'll talk about how it works. So once again, you open up the app builder, you describe what you want to build. Here's the prompt that was generated by ChatGPT to make us essentially an allocation engine that'll take in the choices of the faculty and then try to find a way to map them onto the groups they would like to be part of. We cut and paste that prompt, stick it into Opal, and then once again, it generates this nice mini app. Let me stop here for a second, and we will go take a look at the mini app. So we're now looking at the Retreat Align mini app, which is going to take the faculty requests as input, and then it'll generate the output, which will map them to discussion groups. As before, you can edit this to your heart's content. This is an input node that gets the Google Sheet containing the faculty preferences. It then goes ahead and runs essentially a allocation engine that will figure out how to map the faculty to the groups. And it essentially describes here in a prompt how to do this without writing code, without over-constraining the solution. It tells it how it wants it to work. From this is actually going to be generated the output, and the output is then going to come in essentially a JSON-like form. JSON is an input form. And this will essentially put this in the right format, which can then be passed along to the final agent stage, which will create a dashboard that shows the mapping of the faculty into their requested groups. And it'll also kind of summarize things like how many faculty got their first choice, their second choice, their third choice, and so on and so forth. And that's what will be ultimately be used by the workshop organizers. So once again, key things to note, we can control how these different stages in this workflow or this data flow mini app are going to be prompted, and AI agents under the hood are going to do the actual work. So let's go back over here, and now we're going to see this everything running. So you can see that we're going to go ahead and upload the comma-separated value list of interests, and that's going to go crank away for a while. I've kind of sped things up. This actually took probably 5 minutes or so to run, and it's going to figure out the faculty grouping based on the preferences given. Once again, I'm not writing any code here. It's generating the JSON output, and then it's going to pass that off, and now we're going to see the result, which comes back as an HTML file. And you can see it tells the total number of faculty, the number of groups that were allocated, the first choice, and then it lists for each of the 5 groups which faculty are in each group. And it also says whether they got their first choice or their second choice, or in, I think it's one case, their third choice. And at the very end, automatically generated by Google Opal, is something saying who didn't get their first choice, so we could go back and look at that more carefully if we wanted to. And that's a very nice sort of summary of what we did. So that's the end of the example of the demo. What I want to do here now is talk about how this fits back into computational thinking. And that's really at the heart of everything here. We're just using AI to help optimize computational thinking. So here we can see we decompose things. We use Google Doc to break stuff up into different pieces. And then we use these different tools like a retreat build and a retreat align to do the actual work. The logic is largely done by Opal with the constraints we give it in the form of these prompts. We're using ChatGPT in conjunction with Opal to sort of idealize and recognize different patterns in our workflow. Opal is doing the abstraction. It's focusing on what we want to do, allows us to focus on the what. It does the how. It also does the bulk of the design and automation. And here we're still doing the validation. As Dan had talked about before, validation is crucially important, but it's also something that if you're going to be doing this for real, you would probably automate. For our purposes, I just wanted to show an example. So I was the validator, and that required a couple of iterations to make sure everything worked. But it was really nice because I didn't have to write any code, and it was always clear where to go back in Opal to figure out how to tweak the different prompts that it had available in its mini app. So that's sort of where we're going to end here. I'm just going to say very briefly, and then we'll take questions. We're working very carefully at William & Mary to prepare our students to be successful in a world that's increasingly shaped by AI. And we have 5 pillars to do this. Let me talk about them each very quickly, and then we'll move to questions. One of the things that's extremely important to us and to other parts of William & Mary is to have a nice option of interdisciplinary degrees. We just launched a major in applied AI, went live. I guess it goes live tomorrow because tomorrow is the first day of class. We also have had a minor in AI for the past year, which was a collaboration between the data science and computer science departments. There's also a new AI ethics minor that is a collaboration between philosophy and computer science with a little help from data science. That is going live tomorrow as well. So it's a great example of William & Mary, left brain, right brain, augmenting, and so on. And then we're also working on a number of other programs with various degrees of completion for a Bachelor of Science in AI. We want to have a Bachelor of Science in Engineering Physics. We want to have majors and minors in bioengineering, and also hopefully a minor in digital media, which will combine the AI infrastructure with work in art, in film, in music, and so on. We're also working very closely with our colleagues in other parts of William & Mary, in particular the Mason School of Business, looking at ways to have bachelor's to master's accelerated pathways. Many of our students come here with a boatload of AP credit, and so they can actually get a bachelor's degree and a master's degree in 4 years. What a wonderful thing, especially as a parent paying tuition as I am, and be able to get further. The only downside to getting a master's degree in 4 years, however, is some employers look at that as master's light. And so we really want to make sure our students have an opportunity to have internships where they get real world work experience, learn about domains, learn about workflows, learn about getting up and going to school, or going to work at 9 o'clock in the morning, a little different from getting up and going to class a little bit later. But the idea here is to make it so that everybody who goes through our programs has work experience by the time they start hitting the job market. Likewise, we also want to make sure our students are able to have an undergrad research experience at some point along the way, either during a summer or even during the year. And this is important, especially in fields like computer science, data science, bioengineering, physics, AI, that change quickly. We want to make sure that our students feel that they're in charge of shaping the future. They're not just like a rowboat that's buffeted around in a hurricane. We want to make sure that they know what it means to work on the cutting edge. So that's also important. And then the final thing, and I'll stop and we'll take questions, we're also making sure that our students are comfortable with digital communication skills. One of the things we see more and more is most interviews nowadays for people graduating college don't involve face-to-face interactions the way it did when some of us graduated years ago, but instead people use things like the big interview system where the student is live, but the quote person who are asking them questions is actually a recording. It's kind of like a half duplex Zoom session. And so we're working with the Career Center, we're working with our student clubs at William & Mary, our AI club, our computing clubs, to make sure our students are very comfortable being able to be conversant and charismatic and witty and on point and so on when they do video interviews. Many students who did not grow up with ambitions to be a YouTube influencer find it a little daunting at first to stare into a camera and be compelling. But that's one of the things we're working on. So with that, I'm going to go ahead and stop sharing my screen, and we'll be happy to take any questions that you might have.
Thanks, Doug and Dan. As mentioned, it's time to transition to the Q&A portion of the program. So please continue to add any questions into the Q&A panel. We'll try to get as many as possible before our remaining time together. So the first one is somebody's developing a platform designed to help families navigate education, community resources, and school partnerships. So you've shown how to create mini apps with AI agents. Could a larger platform simply be a collection of connected mini apps? Each powered by its own specialized agent? And if so, what are the best practices for scaling that approach?
Dan, you want to take that one?
Yeah, and I just responded to this in text. I didn't realize we were gonna have time to do this. This is perfect. This is basically how most software is engineered today, even outside of the agentic framework, where you'll have kind of one overarching goal and lots of subcomponents of your program that are trying to build towards that goal. This is also how agentic systems are being integrated. So the most common approach you might see is you have a lot of different agents that are working together on a shared project where they interface through a single database. In our own department, I'll give you a silly example of how we've architected a similar project. We have TV screens all over the place, and the TV screens show the events that are coming up in data science, highlights of our research, and kind of exciting things that are going on across William and Mary. So every morning, 3 different agents run. One looks at our LinkedIn feed to find cool stories of what we're working on. One looks at our events feed to figure out what events we want to highlight, and one looks at the William & Mary homepage to figure out what big events are going on that day. And each agent then writes to a database that our TVs ultimately read from. If one of those agents fails, that's fine, right? Because the other agents will continue to run. It lets us diagnose problems more effectively and isolates potential problems. And again, this is not new. This is how software has been engineered for decades now.
Yeah, and what's interesting about what Dan was saying is before we had to have a person who would sit there and do all those things, and inevitably that person got busy, and inevitably things would fall behind, and so you'd come into some of the buildings before we moved into our wonderful new building, Integrated Science Center 4, with AI agents, and you'd find messages on the TVs that were from like a year ago. And the great thing now is things are up to speed. It doesn't really cost much of anything to do this. It was a great project to figure out how to use agents. And it also reinforces the point that both Dan and I have been making about finding ways to optimize your workflow, where you look for ways to see what you're doing day in and day out, or what you and your team are doing day in and day out, and find ways to automate the places where it's not really adding a lot of human value to be in the loop. We obviously want to check to make sure that what's going up on the TV is sensible, but it's not something that requires a lot of care and feeding anymore. And those are the kinds of things that free us up to spend more of our time focusing on the stuff that AI agents don't do as well. That's the creative part. And that's why it's really exciting. We're really very jazzed about the creative dimensions of this because it unleashes new opportunities for innovative thinking.
All right, and the next question is how to connect agentic tools to various applications, and then and with that, what's some of the risks of connecting those to the applications?
Dan, do you want to talk about the MCP stuff you've done and some of the other things you've learned with Claude Code?
Yeah, absolutely. As Doug just alluded to, the most common way that you link AI tools into other platforms is through what are called MCP protocols. And MCP, I can't remember the acronym off of the head, but
Model control protocol. That's what MCP is.
There we go. Model control protocol. These are essentially instructions for AI agents of how they can use other software platforms. So there might be an MCP for Microsoft Word, an MCP for Microsoft Excel. One of my favorite MCPs is one for Roblox that my kids can use to create Roblox games for each other and share them with their friends. And essentially what that lets you do is in your kind of Opus or ChatGPT interface, you can type in instructions for something you want the AI to do in another software program. Those are common. They're if you Google MCP server for blank, it will almost certainly exist for the software that you're looking for. Now, there are, of course, big challenges with that. Once you've given your agentic tool access to those software platforms, they can use them. And so if I were to give access to my AI tool to, say, William and Mary student data, it would be able to use them. And there would be serious FERPA concerns about that. And so, you just like any other human that you are instructing to do something, you have to make sure that you're not getting access rights that the tool should not have.
Yeah, and it's worth pointing out, for example, the the tools like Codex, which is an OpenAI tool, Claude Code, there are other ones that exist as well. They give you the option to decide what degree of permission or degree of access you're willing to grant different parts of those tools to your personal space. The nice thing about using Opal, as we saw, was I had to go and manually decide which files to upload to it. So it was much less likely to accidentally root around and send my credit card numbers or whatever else might be lurking on my computer disk somewhere. So you do definitely have to think about that. As Dan says, we're that way in everyday life. You're pretty careful who you give your credit card numbers to or your social security numbers to. And agents are really no different. So you just need to think of an agent as sort of a very fast moving friend. And you have to decide how much you're going to trust that fast moving friend with your personal identifiable information.
All right, next question says the current news tells us that jobs are harder to find for graduating students. Are the video type interviews that you mentioned there earlier, Doug, are they now the norm no matter what field the student majored in?
I wouldn't say no matter what discipline or what field the student majors in. Some fields are going to require more face-to-face interactions than others, but we're definitely seeing that is the by far the norm. By the way, coming back to the issue of jobs being hard to get, that's why we have this five-pillar plan to make sure that our students do internships and research opportunities and so on and interdisciplinary degrees. So they're going to stand out from someone who's just gone and done maybe book learning in one discipline. And I was just talking to some of the students who came back. Tomorrow is the first day of school at William Mary. And so many of the students who went on internships this summer came back saying, I'm excited because I've got a job with that company next year after I graduate, which is just absolutely fantastic. In fact, one of the students was telling me that the company that she worked with this summer has actually agreed to finance her master's degree. She's going to do a bachelor's to master's accelerated pathway here at William Mary, and they're actually going to pay for her getting a master's degree, and then she's got a job. So these strategies are really paying off, and we have really talented students here who deserve to leverage their competitive advantage by having the jobs of their choice by the time they graduate.
Thanks, Doug. And then last question, automate tasks based. One of the users wants to automate tasks based on emails in my Gmail box. What are some steps that they would be able to take?
Yeah. Can I take this one, Doug? I just did this.
Please, yeah.
So you can do this right now through ChatGPT Pro, and it's trivially easy to do, and it was kind of shocking to me how trivially easy it was to do. This used to be something that you had to do so much more complicated stuff for. On ChatGPT, if you connect your Outlook or Gmail account, you can do either one. It will basically allow you to interface with it, and you can prompt things like, please give me a list of those important emails for me to reply to, and it'll give you a list. And then you can say, oh, well, that first email, can you please write a reply to me? If there are scheduling emails, it will automatically write emails to your or scheduling opportunities to your calendar, all sorts of exciting stuff that it will do that will free up time. What I have found, though, the downside of this is that it's very, very good at handling those emails that don't require any brain power. And so what you're left with is all the other emails that actually require you to figure out what the solution to a problem is. So a bit of a mixed blessing. It lets you gives you more room to kind of focus on things, but at the same time, makes it so what you're focusing on is generally the harder stuff.
And then you should probably also mention the fact that it doesn't just blindly respond and then send the emails. You get a
No,
chance to review
you have
and
to click
reply.
send. Yes. Yes, you definitely have to click send. It will not do it for you.
It's also funny because one of the things people typically do when they get overwhelmed with too much emails, they start to get terse and pithy and perhaps not as kind and gentle and loving with their responses as they might otherwise be if they weren't inundated with emails. And that's another place where AI really shines because it can make sure that you have a consistent tone and you're always replying in a helpful, friendly, considerate way. And there's just so many things like that where AI can make people more productive.
One of the really neat things about that email integration as well, and by the way, there have been many email integrations over the years. You can request ChatGPT or Claude or whatever tool you're using to rewrite emails in your voice based on all of your previously written emails. And so it really does. And I mean, I edit these emails a little bit before I send them generally, but it really does a pretty good job of capturing your voice. It's not too verbose. All of that type of stuff has been resolved over the last few months.
Yeah, and that's another good thing to point out just generally about AI. This isn't necessarily specific to agents, but as you use these tools, as you use Claude, as you use ChatGPT and whatever, it starts to figure out who you are. And you can say things like, do an analysis of this proposal from my perspective. And it knows what your perspective is because it's been kind of keeping track, like Santa Claus, of everything you've been doing over all the time you've been using it. And so to Dan's point, it really is like having a clone of yourself. And of course, it's still helpful it's still necessary and important to review before you hit send or before you go ahead and submit a paper or whatnot. But it really does a nice job of channeling what it knows about you. And this is something I think people sometimes take for granted is the more you use these tools, the better off they become at knowing how to be like your agent, your worker, your helper, your personal assistant, if you will, which is just fantastic.
All right, thanks. That's all the time we have for today. Doug, do you have any closing comments?
Nope. Thanks everybody for attending. As we've mentioned before, we will put this up on our website and keep your eyes out for the next tutorial where we'll continue to go and look in more depth at other exciting areas that AI is evolving into.
Yeah, and special thanks to the William and Mary Alumni Association and the Lifelong Learning Series for making this program possible. As a final reminder, recording of today's webinar will be available on the William and Mary Alumni YouTube channel within the next week, so you can revisit the demonstrations and share with them colleagues and friends. But thank you again for your continued support of William and Mary and your continued commitment to lifelong learning. Have a wonderful day.